Welcome back to another video, and today we will be looking at a problem from the Asian Pacific Maths Olympiad, a competition which comprises of different countries from the Asian and Pacific region, which is quite difficult. Find all pairs AB of positive integers such that a cubed is a multiple of b squared and b minus 1 divides a minus 1. Please pause the video and then give it an attempt, but for now, we will jump right in. We can deduce some simple observations here. First of all, if b is smaller than a, then b minus 1 is smaller than a minus 1. But b minus 1 is a multiple of a minus 1, which implies b minus 1 is larger than a minus 1. Therefore, b is equal to 1. And if b is larger than or equals to a, let a cubed equals to k times b squared. Then for some positive integer k, since a is congruent to b, congruent to 1 mod a minus 1, we will have 1 cubed is congruent to a cubed, which is congruent to b squared k because a cubed equals to kb squared, which is congruent to 1 squared k since b is congruent to 1 mod a minus 1. And therefore, we'll have this really nice result, which is k is congruent to 1 mod a minus 1. And we will observe how we could use this condition. So the first case, if k is smaller than a, then k would simply be equals to 1, because k minus 1 is a multiple by a minus 1 through k congruent to 1 mod a minus 1. Therefore, k is 1 if k is smaller than a. Therefore, a cubed is equals to b squared, and there exists a positive integer d such that a is equals to d squared and b equals to d cubed. This implies d squared minus 1 divides d cubed minus 1. Factorizing both sides, we would have d minus 1 times d plus 1 divides d minus 1 times d squared plus d plus 1. Since d is not equals to 1, we could remove the d minus 1 for both sides, and we would have d plus 1 divides d squared plus d plus 1. Taking the common factor d, on the right hand side, we would have d plus 1 divides d times d plus 1 plus 1, and since d times d plus 1 is multiple of d plus 1, this implies d plus 1 divides 1. Therefore, d plus 1 is equals to 1 or negative 1, which implies d 0 or negative 2, which is more than or equals to 0, and thus we have a contradiction. In the second case, if k is larger or equals to a, then we will have b squared k is larger or equals to b squared a, which is larger or equals to a cubed because b squared is larger than or equals to a squared, and a cubed is also equals to b squared k. And since b squared k on the left hand side is equals to b squared k on the right hand side, this implies equality throughout. Therefore, b squared a equals to b squared k, we will have a equals to k, and b squared k a equals to a cubed, implies a equals to b equals to k. And if we check, we can easily find ab and a1 satisfy the equation, and this completes our proof. I hope you've enjoyed the video. Please like, comment and subscribe, and as always, we will see you until next time.